All of you see? So see here, beta. In last class, the topic where we have left, that is was discussing at that time, was acceleration. बेटा एक्सेलरेशन को हिंदी में बोलते हैं त्वरण, जैसे होता है ना बेटा त्वरित कार्रवाई, तो एक्सेलरेटेड acceleration. How we can define acceleration? Symbol is A. What is the symbol A? Because this is the vector quantity, so the symbol is A. What is acceleration? The rate of, what is the symbol of acceleration is A. The rate of change of velocity. The rate of change of velocity. The rate of change of velocity with respect to time. With respect to time is called acceleration. Velocity, just I have defined you. Velocity consists of two terms. Velocity consists of two terms: speed plus direction. So see here, if I'm moving in a circular path, your speed remains constant. For example, 40 meters per second, but your direction is keeps on changing. So acceleration occurs. So either the speed remains constant, but direction should change. So this is the example of accelerated motion, where the speed remains constant, but you are moving in accelerated motion. Second type is you are moving on a car, and your car is moving on a straight pathway. Your direction is not changing. If your direction is not changing, better, but what is going there? Your speed keeps on changing. Initially, your speed was 20 meters per second, after the 30, after that 40, after that 50, after the 60. In every 1 second, your speed increases by same amount. That is every 1 second, that is when this motion starts at time 0. Your initial velocity was 20. Your speed was 20. After 1 second, your speed will become 30 meters per second. After next 1 second, your speed becomes 40 meters per second, or 50, then 60. It means that your speed increases by a constant, a fixed amount. So this is also example of accelerated motion. This is also the example of. Now let us see, if you are moving on a car on a highway with a very large speed, that is your speed 80 meters per second, and you are applying the brakes. After 1 second, it becomes 70 meters per second. After 1 second, next 1 second, it becomes 60. After it becomes 50, 40, 30. So in this case, the speed is decreasing. So we can say that retardation occurs. We can say that retardation, negative acceleration. So negative acceleration means your speed decreasing. I'm telling here speed in a definite direction, that is velocity. Now, if the velocity decreases by fixed amount, so this is called negative acceleration. If your velocity increases in every 1 second by fixed amount, this is called positive acceleration, and this is called negative acceleration. Negative acceleration is called retardation. So such type of retardation, negative acceleration or positive acceleration, is called uniform acceleration. It's called uniform acceleration. It's called uniform acceleration. Wait. But see here, let us see the example of uniform accelerated motion. If you are dropping any body under gravity, what will happen? Because of the gravity force, because of the gravitational force of attraction, the ball or any body it gains velocity. And in every 1 second, the speed increases by fixed amount, that is 9.8 meter per second. In every 1 second. So second into second, 9.8 meter per second in every 1 second. That is called 9.8 meter per second square is the acceleration. So if any body is allowed to fall on the surface of Earth, then because of the gravitational pull of Earth, in every 1 second, beta, how much velocity increases? Beta, tell me, how much velocity increases, beta? 9.8. Fix. If you throw the same body in vertically upward direction, body is moving upward, but the gravity is pulling it downward. So the velocity of the body will decrease. Velocity of the body will decrease. In 1 second, how much velocity decrease? On the surface of a 9.8 meter per second. This is fixed. So 9.8 meter per second in every 1 second change in velocity is called acceleration. It's called acceleration. So this is example of motion under gravity. Now you see here. So acceleration may be uniform. So what is acceleration? Acceleration is change in velocity. Acceleration is change in velocity with respect to time. Now what is uniform acceleration? Uniform acceleration. What is uniform acceleration? See here, if the graph is like this, velocity versus time graph is like this. Slope is constant. Slope is constant. This theta, tan theta. Tan theta is called slope. That is dv by dt. Rate of change of velocity. Y-axis, dy. dy is dv upon dx. P by d is called tan theta. That is called slope. P, what is P? बेटा P क्या है? Change in velocity. और base क्या है बेटा? Change in time. Change in time. This is called acceleration. Since the बेटा क्या है? Its graph is constant. तो बेटा क्या होने वाला है? Acceleration is uniform. Why? Because slope means tan theta. Remain constant. Slope is constant. So slope constant means in every 1 second velocity increases by fixed amount. Now such type of motion is called uniform accelerated motion. Now let us see here. Can you tell me beta what is the acceleration of body A and acceleration of body? This is 0. This is 10 meter per second. This is 20 meter per second. This is 30 meter per second. Time is 2, 4 seconds. And this is 6 seconds. And what is the acceleration of second body? B. Yes, tell me. Yes, but all of you, can you tell me what is the acceleration of body A? Now, see here. Acceleration of body A. Acceleration means, since we are not finding instantaneous, the slope is uniform. So we can write delta because finite time interval is known. Instantaneous will be asked. If you are asked to find the velocity at a particular instant of time, then you have to apply this formula. But if graph is constant, you have to apply delta sign. Delta means change that we can observe easily with the help of graph. In the graph, it is clearly represented. What is the change in displacement for body A? What is the change in velocity for A? Change in velocity of A. So change in velocity means final velocity minus initial velocity upon final time minus initial time. Now tell me beta, for A, what is the initial time? 0. No, initial time 0 minus final time. But a final time graph reaches here. Final time is 6. Now see here. For graph A, what is the final velocity? When the time becomes 6, the final velocity becomes 30. Final velocity becomes 30. What is the initial velocity? For graph A, the graph starts from here. The initial velocity is 0. So what is the acceleration? 30 minus 0, 30. 6 minus 0 upon 30 upon 6 is 5 meter per second square. So what is the acceleration of A? This is 5 meter per second square. 5 meter per second square. Now beta, all of you see how we can determine the acceleration of body B. For body B, let's see here. For body B, same formula, final velocity minus initial velocity upon T final minus T initial. Beta, for body B, what is the final time? 6. Final time is 6 minus. What is the graph starts from here at 0 second. At 0 second. Because the time starts from 0 to 6. Initial time is 0. Now tell me, at 0 second, for graph, this is the graph of body B. At time 0, where was the graph? For body B, where is the graph? At time 0 second, the graph is at 120. So initial velocity is 20 minus. At 6 seconds, the graph reaches here. So this is velocity axis. You put perpendicular. Any point over the x-axis, y coordinate over the y. What is the coordinate? Velocity. So the point, this point is at 6 seconds. So y coordinate over the x-axis becomes 0. You put perpendicular. See here, what is 0? Velocity. Velocity is 0 at 6 seconds. 0 minus 20 upon 6. It is minus 3.33 meter per second square. So see here, beta, this is the acceleration. The negative value tells us what? The slope is like this. Negative slope, this is positive. So that's why for body A, this is positive slope, anti-clockwise angle. For body B, with the x-axis parallel to x-axis, you draw here, the graph becomes, the angle becomes clockwise. Clockwise means inward. Inward, negative acceleration. With the negative x-axis, this is graph is like this. Anti-clockwise, positive acceleration. Now see here. This is increasing slope, positive acceleration. This is decreasing slope, negative acceleration. Increasing slope and decreasing. This is decreasing negative slope. This is positive slope. That's why see here, the value comes out to be minus 3.33. Equation of uniform accelerated motion. See here, equation of uniform accelerated motion. Uniform accelerated motion. Let us see here. This is the graph. This is the initial velocity. Over this axis, this is time, 0 time, and at time t. At a particular instant of time t, whatever be the velocity, that is called final velocity, represented by small v. And at time 0, what is the velocity? Initial velocity is small u. And this is the theta. Tan theta is called slope. Now see here, since the most graph is a continuous graph having constant slope, angle is not varying. So velocity versus time is called acceleration is uniform acceleration. Acceleration is called uniform acceleration. Now see here, beta. We can write A is equals to differential rate of change of velocity in differential time t. Now you see here, we can write dv is equals to this, come this side, it will be get multiplied. Now change in velocity, it occurs from 0 to time t. It occurs from 0 to time t. Now let's see here. Let this time is, we make certain different time t like this. At a particular instant of time, let at time t, the velocity becomes v. Now we can write v is equal a is equals to dv upon dt. Dv upon dt. That is a acceleration at particular instant of time is rate of change of velocity with respect to time. This is in denominator side. When this will go left side, it will get multiplied. A into dv is equals to dv. Integrating above equation. But us here, integration means what? What is the total sum? What is the total change that takes place to sum up this whole change? What is integration? To find out the total change that takes place is called integration. Integrating above equation by taking proper limit. Why we are talking about the proper limit? Let us see here. dv. Here the velocity changes from u to v because the at time 0 graph starts from here. And as the time passes, the graph reaches this time, the velocity becomes v. So at time 0, see here, a is constant. During integration, we keep constant term outside. Just remember, we have already discussed beta a into dt. A is constant, uniform, constant. So we keep constant outside. Only the variable term. We will integrate only the variable term. Now, what is time? Initial time is what? 0. What is the final time? This t. No, not this t. What is at time 0? What is the initial velocity? U. And at time this t, the velocity becomes small v like this. But see here, dx. बेटा see here, सक्षम बेटा see here, बेटा कोई भी एक constant quantity है x to the power n into dx. You see here, you see my video on integration where I have explained each and every parts of integration. You go through that video. But see here, if this is given, the integration, that integration will be x to the power, this is power. Its power increases by 1 unit and this power comes in the denominator also. And we put modulus sign. Here lower limit will be given just like this. What is the lower limit? U. This is the change in velocity from u to v. Similarly, this is the lower limit a and upper limit v. It means the value of x changes from a to b. So lower limit written here, upper limit written here. After that, what is the next step? We take constant term outside, 1 by n plus 1, we take constant term outside. And after that, this is the variable term, so the upper limit is b. But x varies from a to b. This is the upper limit. So first put upper limit in place of x. Whatever with the power you write as it is, n plus 1. And then put upper limit, after that put minus sign. Then you put lower limit here. In place of x, a. Whatever be the power, you write as it is. And now solve it. So this is the first formula for integration. This is the first basic formula for integration. You should know this one. Now see here. Let us see here. What is the power of v here? Only dv is there. Only dx is there. It means, see here, we can write dv as, how we can write d? Just remember this formula. Just remember this formula. But we can write dv as, after this, you come here. We can write dv as v to the power 0, something to the power 0, 1. But we can write dv as v to the power 0 into dv. Then put here. U to small v. Final velocity small v, initial u, initial velocity. Small u, initial velocity. A into dt. dt means t to the power 0 into dt. Why beta? Something to the power 0, 1. If we multiply 1 with any physical quantity, it will not affect. Similarly, v to the power 0, 1, 1 into dv. Now see here. 0 to this time t. Now, but during integration, see here, what is the integration of v into dv? What is the power? 0. So power v is 0. Power 0 plus 1 is See, n is power, n is the power. Power is here, it is 0. 0 plus 1, 1. So put here v to the power 1 and same power comes down. So 1 v to the power 1 v upon 1 v. So just remember integration of dv is always v. Similarly, we will put a integration of dt is t. Always remember put modulus sign, write lower limit, write upper limit here. Now after this let us see. Let us see here. First put upper limit small v minus, then you put lower limit. What is power 1? So 1. Then put lower limit u. Power 1 a. What is the lower limit? 0. Upper limit is this t. Final time. What is the upper limit? First put upper limit minus lower limit 0. T minus 0 t a t is equals to v minus u. Minus sign goes this side. V is equals to small u plus a t. This is v is equals to a t. This is known as the first equation of motion. This is known as the first equation of motion. Now you see here, but you always remember this formula. Now you see here. But see how we can write this equation. How can see? Now, beta A is equals to, or you may write V is equals to dx upon dt. Velocity. Now we are deriving second equation. Now you see it. We know that velocity is equals to rate of change of displacement with respect to time. Now you put the value of v here. What is the value of v? U plus at. V is equals to u plus at, like this, is equal to dx upon dt. Now you take t here. Now you take t dt this side. You rub this one. This is the first equation. Now you take this. U plus a t into dt is equals to dx. See here, integrating above. What is dx? Displacement moved by the body. What is dx? Displacement moved by the body. Now, integrating above equation. Integrating above equation. It means what we are integrating? Total displacement moved by the body. Through second equation, we will determine if the body starts with initial velocity u and it is continuously increasing its speed v, then what is the distance moved? But in class 9, you have studied about the area below the graph. This not only. This one also. Area below the graph is this triangle area plus this rectangle area. This whole sum. So what is this rectangle area? Velocity u breadth into length t, ut, plus what is the area of the triangle? Half into base. Base is what? T. Into height. Height is what? Total is v. This is a. This is v minus u. V minus u. Now divide here t multiplied by t. V minus u upon t is acceleration. V minus u, beta see here just for we have derived v minus u is equals to at. T takes here. Change in velocity. V minus u upon t is called acceleration. Half at square. So total area ut plus half at square. In class 9th you have derived this formula. But here we will derive this formula s is equal to ut plus half at square. Beta see here. All of you see. In case of velocity time graph, if the graph comes out like this, then you draw the whole area below this. Said I did. The total area is the displacement moved by the body. The total area is the displacement moved by the body. If this area is above, that is velocity is positive. This is positive displacement. If this area comes out below this, it means velocity is negative. The displacement will be negative. Now see here, integrating above equation by taking proper limit. dt multiplied both sides. You take dx. Dx is the displacement, a small displacement. Now the body starts from the origin and total displacement is s. Do you remember in class 9th what was the displacement? What is the symbol of displacement we take? S. S is the distance. Distance and displacement in this case will be same. Why? Because the body is moving in a straight line. But when the velocity becomes negative, then only displacement will be negative. If the velocity remains positive, displacement will positive. बेटा देखिए इधर वेलोसिटी जब तक पॉजिटिव रहेगा डिस्प्लेसमेंट पॉजिटिव रहेगा, वेलोसिटी जैसे ही नेगेटिव होगा डिस्प्लेसमेंट नेगेटिव होगा. सी dx u into dt, u constant है बेटा, take it outside, plus a t into dt, integrating. What is the initial time 0? What is the initial time 0? Final time t, final time t. बेटा see here, just we have discussed integration of dx is x, 0 to integration of dx is x, just we have discussed. अब देखिए बेटा आगे, upper limit s, lower limit here, u. What is the integration of dt is t, lower limit is 0, upper limit is t plus a. Beta, what is power 1? So increase the power by 1, n plus 1. Its power become 2. 1 है बेटा 2 करे वही पावर नीचे. बेटा कितना सिंपल इंटीग्रेशन है. पावर 1 है बेटा 2 करना है वही पावर नीचे. बस ये सिंपल सा रूल याद रखना. Now see here, put modulus and what is the lower limit 0, upper limit is this time t. Now see here, upper limit s minus lower limit 0. बेटा पहले upper limit को रखते हैं, then we put what, lower limit. S minus 0 is s. Now you put u. What is the upper limit? T. The upper limit minus lower limit is 0. Plus 2 comes out, a by 2. Because 2 is constant. What is the upper limit? T square minus g square. What is the formula? S is equal to ut plus half 1 by 2 a t square. But you have already studied this formula, this equation, second equation of motion in class 9th. But here we have derived this by using integration and differentiation method, that is calculus method. So in class 11 you will be asked to derive the formula by calculus method, not by graphical method or not by the simple formula method. You will be asked to derive by use of this calculus method. Now this is the second formula. Now see here beta, will end up just within 1 minute. See here, you know a is equals to dv by dt. Acceleration is equal to change in velocity upon time. बेटा अगर यहाँ हम dx से मल्टीप्लाई कर देंगे क्या फर्क पड़ता है? dx बेटा ये तो कट करके 1 यही का यही आ गया. अब बताइए बेटा dx अपॉन dt क्या होता है? रेट ऑफ चेंज ऑफ डिस्प्लेसमेंट विद रिस्पेक्ट टू टाइम इज वेलोसिटी. क्या होता है बेटा? वेलोसिटी. यहाँ लिख सकते हैं v into dv अपॉन dx is equals to a. तो बेटा a को इस तरह से भी लिखा जा सकता है, a इधर आ जाएगा, a into dx is equals to v into dv. Now again integrating above equation, बेटा क्या करेंगे इससे? Listen here, a into a constant, take it outside, v into dv, change in velocity from u to v. Beta, what is the power? 1, so power becomes 2, increase 1 by 2, lower limit u, upper limit v. What is the integration of dx? X, 0 to s, total distance x, 0 to s, put upper limit s minus lower limit 0. First upper limit small v square minus then lower limit u square by 2. S minus 0, s, as, 2as is equals to v square minus u square. This is the third equation of motion, or we can write this like this: v square minus sign come this side, u square plus 2as. But this is the third equation of motion. Now we have derived all the three equation of motion. Now